In this video, I demonstrate the process I use to make resin copies of bodies and other parts using silicone molds. The process shown is one that I have used for the last 30 plus years, and it has evolved over that time. It is not the only way to cast parts, but it is what works for me. The body used in this demonstration will be a 1957 Dodge D400 cab that I modified from a Matchbox 1957 Dodge swept side casting. The process I use for making molds and casting parts is called pressure casting. It requires that the silicone rubber molds and resin cast parts be cured under a pressure of approximately 40 psi. The curing is done in a pressure tank that I converted from a 2.5 gallon pressurized spray paint tank. I have found that with curing under pressure, I no longer need to use a vacuum chamber to degas the silicone or the resin. In my opinion, this method reduces the likelihood of failed castings due to air entrapment, but may require additional planning when creating the mold. My plan was to place the cab upside down in the mold and fill the mold from the center of the cab roof. With that in mind, the cab would need to be positioned at a slight angle to help with the flow of air out of the mold. In this side view, the green line represents the fill sprue, and the red lines represent the air vents. To visualize how filling the mold works, the resin flows into the mold via the sprue, the black arrow, and as the level of the resin in the mold rises, the white line, the air within the mold escapes through the vents created at the high points in the mold cavity. These are the pieces that were used to make the mold box. The base is a rectangle cut from 5/8 inch thick melamine shelving board. The four sides were cut from 1/4 inch thick Paylite foam PVC sheet, because that's what I happen to have on hand. The mold box was sized to allow about 3/8 of an inch extra around the sides of the cab and about 1.5 inches extra in height. In order to successfully cast the cab in resin, I needed to make sure there were paths for the resin to fill the mold completely without trapping any large air bubbles in the part. To help with the flow of the resin, a bridge of thin styrene sheet was added between the roof and the cowl. The flat window areas of the cab were sealed from the inside using cellophane tape. Those areas are colored blue in these photos. Sculptex non-hardening modeling clay was used to seal off the remaining curved windshield areas and to support the cab in the mold box. To avoid having to completely fill the cab with Sculptex, a vent hole was added to the base to allow the air pressure from the cavity inside the cab to equalize with the pressure outside the mold box. With the cab attached to the base, I used hot glue to fasten the sides of the mold box to the base. Hot glue and blue tape were used to ensure there were no holes in the box seams for silicone to leak out of. There are two primary types of silicone used in making molds: platinum cure and tin cure, which is sometimes labeled condensation cure. The platinum cure silicones are very sensitive to certain elements such as sulfur, which will prevent them from fully curing, so I tend to avoid using them. For this mold, I use Smooth On Mold Max 10, which is a tin cure silicone that is less sensitive and will fully cure in a broader range of conditions. It is also one of the lower viscosity silicones, so it is less likely to trap air bubbles in the mold. After estimating how much silicone I would need based on the size of the mold box, that quantity was mixed following the ratio on the packaging. The mixed silicone was then slowly poured into one corner of the mold box and allowed to flow over the cab casting until there was about 3/8 of an inch of silicone over the highest part of the cab. The mold box was allowed to sit for about 5 minutes to allow trapped air to rise to the surface. It was then carefully transferred into the pressure tank. The tank lid was closed and clamped in place, and the tank was pressurized to about 40 psi. At this pressure, any remaining small air bubbles in the silicone should have collapsed, leaving no voids in the mold. After allowing the mold to cure for about 12 hours at 40 psi, the pressure was released from the tank and the mold box was removed. The mold box was then carefully disassembled and the Sculptex cab support was removed from the cab and the first half of the mold. A length of styrene rod was glued to the roof of the cab to serve as a fill sprue for the second half of the mold. A long 256 screw was added to the cab mounting post to create an air vent in the second half of the mold. The mold box was reassembled around the first mold half, and mold release was applied to the first mold half. Applying sufficient mold release is very important at this point to ensure the silicone for the second mold half does not bond to the first mold half. The second half of the mold was created following the same mixing, pouring, pressure casting, and curing steps used in the first half of the mold. After the second half of the mold was cured, the mold box was disassembled and the mold halves were separated. Additional air vents were hand cut into the second half of the mold. To prepare the mold for casting, I dusted both mold halves with talcum powder, removing any excess with compressed air. I have found that the powder makes the mold halves slide together more easily and helps the resin flow better. The outer portion of a 10 cc disposable syringe was then pressed into the fill sprue to act as a fill funnel. The syringe allows for excess resin to create a little extra pressure that helps the resin flow into the mold quickly. For this mold casting, I used smooth cast 305 resin, which has a 7-minute working life and a 30-minute cure time. For this mold, 10 cc's should have been more than enough resin to fill the mold. In this example, I accidentally mixed twice the amount. Equal parts of smooth cast 305 were mixed thoroughly for about 1 to 2 minutes before being poured into the prepared mold. As the resin flows into the mold, you can see the level on the syringe dropping as the mold fills. Eventually, resin can be seen flowing out of the mold vents. At this point, the mold is carefully transferred into the pressure tank, the tank lid closed, and the pressure applied. After about 45 minutes, the pressure is released and the mold is removed from the tank. The mold halves were then carefully separated. A little compressed air was used to assist in separating the mold halves and removing the finished part from the mold. After removing the fill sprue and vent runners, the finished part is ready for final cleanup and use. Thanks for watching. I hope you found this informative and helpful.